Welcome, everyone, to this second AI lunch talk of the fall, the second out of 4. Next time, we're actually not going to be here in Skylab. We're going to be at the Digital Tech Summit in Østenhallen in Copenhagen. But if you're joining online, that's not going to matter to you, of course. I'm going to share after the talk, I'm going to share a few QR codes so you can sign up for the next ones. But today, we have the pleasure of having Rockwool visit us. We're supposed to also have Implement here, but unfortunately, Victor got sick and has been having a high fever all through the night. So we're sending good healing vibes to him and hope to see him in the spring, perhaps, for Applied AI Lunch Talks. Today, we have Shabab Akhtar, who's going to be sharing with us about how Rockwool is making use of AI and machine learning to optimize their production. So without much further ado, I'll let him do the detailed introduction himself and welcome him here on stage. Please give a hand to Shabab.
Yes, I hope you can hear me.
Yes, yeah. And I should perhaps mention that we'll take the questions afterwards. And if you have a question, call me over. I'll bring you the mic so people online can also benefit from your questions and the answers.
Yes. So I would just like to start by saying thank you to Camilla and D2 Skylab for having me here and giving me the chance to speak a little bit about what we are doing at Rockwool and more specifically some of the projects that I'm working on at Rockwool. So before I introduce myself, what I will talk about today is how we are utilizing AI and machine learning at Rockwool, where we have some large and complex manufacturing processes. And to those who don't know much about Rockwool, we will also have a little introduction to that. So, but also just some general housekeeping before I get into it, also to let you know whatever I show you and tell you here today, it's mostly my views and not necessarily the views of Rockwool or any associated partners. So just to get that out of the way. And then agenda, so I will start with the introduction to myself and also an introduction to Rockwool. And then move on to what a very short intro to AI machine learning and also how it is related to the manufacturing industry and what it means in that context. And then we dive into some concrete use cases where we look at predictive maintenance, where we will have some brief look into one of the projects that I'm working on right now. And then we will also go through another use case, computer vision use case, which is something that one of my colleagues is working on. But I will show you some videos of what we are doing in that space. And then finally, a short wrap-up and a chance for you guys to ask questions. All right. Then we can start with the introduction. So as you have heard, my name is Shabab. I originally come from Bangladesh. And I have came to Denmark to do my master's in computer science, not at DTU, surprise, surprise. But yeah, I was actually at STU in Odense, where I did the master's in computer science and specialized in data science and did a year-long thesis on model explainability, so explainable artificial intelligence and stuff like that. And then after that, I've been working for a few years now, working in sort of the technical field for about 5 years. Worked as a software engineer in the past, worked as a product owner also in the past. And then in most recent times, I've been working as a data scientist for about 3 years, and some or most of which has been in a consulting setting as well. But now I'm at Rockwool. I've been here for almost about a year now. And here I work mostly like an internal consultant, where I'm based out of the digital department, and I try to find innovative solutions for different parts of our business. So that can be at the factories, where I would try to optimize processes or do something with quality control, but it could also be with the marketing team, it could be with the finance team, so it's quite broad. So that's where my consulting experience from the past also plays a huge role in what I do today. Okay, then we move into a brief introduction to Rockwool. So there's a big process. I will not go through that step by step, but to summarize, what we sort of do is we take stone or volcanic stone and melt that at very high temperatures at around 1500 to 2000 degrees. and then we spin that melt into wool. So the closest analogy would be basically candy floss. And in this case, instead of the sugar, the raw material is stone or broken down stone. And the mixture, of course, contains a lot of other chemicals, but it's primarily the concept is we take stone and melt it and spin it into wool. And then, of course, as most of you probably know, what we do with it is our core product, which is building insulation. So what you would put in between the walls at your house to keep the indoor warm or cold for longer periods of time. But that is actually not the only product that we have, and this is interesting for most people. But we actually have quite a lot of other products, such as Grodan, which is a horticultural product. So a lot of the tomatoes and cucumber in Europe is actually grown in one of our products, which is called Grodan. And then we also do, I think, this thing called rock panel, rock phone, which is usually the tiles on roofs. I don't think it's this one, but on roofs, which is for acoustic purposes and sound, better sound quality in the room. So it's not just building insulation, and there's a whole lot of other products that we are also doing. Okay, then we can look a bit into the AI and machine learning in manufacturing. But before that, just a bit about AI in general. I'm sure most or all of you here know about it, so I will not go into defining what it is, but I take a quote out of one of my role models in this space, and I'm sure everyone knows who Andrew Ng is or have done a few courses of his if you are interested in AI machine learning. And one of the things he said a few years ago was that he fails to see or think of an industry that AI will not transform the way electricity had transformed everything that we know a hundred years ago. And this is of particular significance and importance because we are lucky enough to be in the phase where we see this happening, where AI is actually transforming everything and every industry that we can think of. But that is not really the case for the building, construction, and manufacturing industry, where, according to a report coming out from McKinsey about 2 years ago, they said that the AI adoption is the lowest in this specific industry. And this is the industry that I'm coming from. So we are sort of at the starting point, and we will go a bit into why this is the case. But one of the biggest reasons is because in the building and manufacturing industry, it's quite conservative, and things move very slow. So, for example, if you've been seeing your houses are always built with bricks, and if suddenly someone says that no, let's do it with board from tomorrow, something wood-based, then it suddenly becomes very difficult for people to think about this. No, but everyone's house has been built with brick, so how can we think of a new material? So the same concept sort of goes through with trying new technologies on the factory level as well. So, but then even though that is the case, there are numerous areas where AI machine learning can be used in a factory setting, and this is also something that I and my colleague we are trying to advocate for at Rockwool and show them that there are many areas where we can use AI. Some examples include for process optimization, where there can be many use cases, such as we are actually having factories in more than 30 countries across the world. And these factories are running nonstop throughout every day of the week, every day of the year. And of course, there's a lot of room for optimizing these processes to produce more product in less time. And these kind of simulations can be done using AI machine learning as well. Then there's of course predictive maintenance, which there will be a case from later today. But here we look at things like, okay, there are a lot of moving parts in factories, such as motors and rotors, that always need to be changed or maintained. And if there's an unplanned breakdown, then it costs a lot of money. So being able to predict exactly when a rotor or motor or any moving component for that matter breaks down is very helpful from a business perspective. And then we also have a very common case from quality control, where you could have products that are being surveilled, that are being seen from a computer vision system to look at, okay, is there a burn spot on this piece of wool, or is the edge not cut out in the right way, and stuff like that. So just use the camera stream to find out defects in the product and push them out if there is something wrong. And then maybe the last point that I make here, which is actually very critical, where every time someone says AI and automation and doing this at an organization and saying, okay, we'll replace 100 people. And this is not a fun thing to say, right? Because, okay, then what happens to these people? But in our industry, we happen to be in this interesting situation where it's starting to become very difficult to find people. Because today, it's not something you would aspire to do, to go and work in a factory, to be a forklift driver. It's not an amazing job to have. It's not something you would tell your kids, like someone would maybe do in the 50s during the Industrial Revolution, that we work at the factory. You know, it's a stable job, but it's not what anyone aspires or dreams to do anymore. So these days, when we lose people at a factory, it's becoming increasingly difficult to find someone else to actually come and work here, because no one wants to do those jobs anymore. So in that sense, using AI and machine learning in the context of our business is very, very critical. And we are almost in a race against time, where if we don't have the technology to take care of these tasks, then we will have a case where the factories are simply not operating because the people are not there, and also we have not had technology to support it yet. So that's also one of the important things to consider. But then we can look at, as I've said, that the AI adoption in our industry is very low. Then we can look at a bit about, okay, why is it low? What are the reasons? Why is it that people don't want to do it so much? And here, the first and the biggest one is infrastructure and security. So what I mean by that is that we have a very spread out infrastructure, whereby we have, as I said before, factories in more than 30 countries. And most of the time, these factories are not connected to the internet. And that's because, in a factory, you have a running production. If you are connected to the internet and there's a hack or something goes wrong, then it can cost the entire production. So usually they have their own local network and running their own business in a closed environment. Then comes AI, and you think, okay, now I have made a model for 30 factories. How do I even deploy it to 30 factories that are not connected to the internet, right? So that is one thing. And then, of course, you have most factories today are built on like PLCs, MES, and warehouse control systems. If some of you know what those are, but they are very primitive logical controllers that are simply that work really well and have been working well for years and years, but they're simply not built to handle AI machine learning. So you cannot deploy a complex neural network to PLCs, which are basically the fundamental backbone on how all factories or most factories in the world today are running. So the infrastructure is basically not really geared to handle the technology as such. Then we also have something that we face on a day-to-day basis, and this is more the mindset of the operators, the people who are actually working on the shop floor, and the ones who would use the tools themselves. And here there's a large gap behind what we envision, what we want to do, and what they have in their mind and how they would like to do it, and how much they trust the solution that is being provided. So this is also very, very critical. And then, of course, related a bit to the first point, but it's also a very complex ecosystem, complex infrastructure, whereby some of our factories, or all of our factories are very, very large and have a lot of different complex machinery connected together and producing something together. So you would often walk for an entire kilometer in total to go from one end of the production cycle to the other end. So you can imagine how many different types of machinery is connected in that space. And then you are trying to build something new that would be placed somewhere, so you would want to move a block out and put a new block in. And that is very complex. Like, okay, if I move this block out, will this production still continue the way that it was going before? So that's also very, very complicated to think about. And then the age-old story that everyone suffers with, it's not specific to manufacturing, which is why I put it at the end, but not that it's not the most important. It's probably the most important as a data scientist, but data availability and data quality is super important. Also because a lot of the times, we are working with a sensor that has been put in place maybe 5 years ago, and no one has really been using it. And it's still collecting data, but you don't really know if the quality is there. Is that sensor still actually performing the way that it was performing? So then there needs to be a project about finding out, is the sensor working? And then you figure out, okay, this doesn't work, then let's put new sensors in, which is another project in itself. So it's the whole data availability and quality aspect is also difficult to work with compared to some other industries with corporate functions where you just get it through your CRM system automatically, for example. All right. So even then, even though we have all of these problems that I just spoke about, of course, we are still doing something. We're trying to do something. We are on a journey. And with respect to that, I will now go into the first use case of predictive maintenance, which is one of the projects that we are working on right now. Here, I will talk about first what is predictive maintenance to those of you who are not fully aware of that, and then look a little bit into where the industry stands today. So not Rockwool, but in terms of predictive maintenance, what is kind of being done at a high level. And then finally, what we are doing at Rockwool from a predictive maintenance perspective. So then we start with what is predictive maintenance. And here, the idea with predictive maintenance is that we want to optimize performance of some machinery, some parts, using sensory values. This is sort of the main thing. I will not go into the details of this because it's maybe a bit too much. But the main goal, as the last line says, is to provide the right information at the right time, because the production is continuous, and that's why it's critical to say that tomorrow something might break, and not an hour before, because that's not good enough. And this is very, very critical. And then also, why or how critical it is. So again, coming out of some reports, I think also from McKinsey, they found out that on average, factories are wasting 15 hours on a weekly basis on unplanned downtime. And while the number 15 is quite low, but this actually results into millions of euros on an annual basis. And also it scales depending on how many factories that you have, or how many different production lines you have. So it is quite significant and makes a big impact. But it is something that can be solved if we are looking at some sensor values such as temperature, pressure, vibrations, and other such things, and past breakdown data. So, and then relate those two to find out, what was the temperature value when there was a breakdown before, and am I seeing certain patterns again? So that's kind of what we can do. And then a little bit about how the industry is. So here you see this is something that was given by Gartner, where in predictive maintenance you can have these 4 steps. So the first is reactive, which is actually where most of the companies in most factories in the world are today, and this is basically fix it when it breaks. So you're just running and you're waiting for things to break down, and if it breaks, then you fix it. The next is where some companies are, and a lot of people are trying to be there, and this is more of the case where you're doing it on a schedule. So most common analogy, your car, how you service your car, you change the oil once a year. It might go on for a year and a half, but you are always doing it in a year. And this is where some companies are, and a lot of people are going to get there. But this one, the predictive one, is the most nice to be place where you would like, where a lot of people are trying to get, where the machine is basically telling you that tomorrow it's going to break, and then you can go and inspect. But even that is not the ideal. So it's to show that the industry is aiming for like second best, even not even the best, because the best is where the machine would actually tell you not that it's going to break down, but rather do this, and this to avoid a breakdown that might happen in 5 days' time or something like that. And this is something that not a lot of people are even comprehending yet. Most people just want to know when is it going to break down. And maybe in 5-10 years' time, we will also start to move towards a prescriptive setting. Okay. Then now I will show some data that I looked at from Rockwool. So I presented the 2 slides that I just showed you. I started a project at Rockwool by showing those slides and saying this is something interesting, a lot of money is being put into it, maybe we can do something. So then I actually started to look at some data, some of our sensory values, and so I've moved the axis, the legend, of course, because of confidential reasons, but what this shows here is over time a value of a particular sensor. And what the time frame here is when a specific part went in and when a specific part went out. And this was an example where it broke down, so they waited for it, so it's not scheduled. It was a breakdown, and then they took it out. But you can see quite simply that the sensor value, this particular sensor value, was just in an upwards trend. And that's where you can sort of tell that it could have been, with a machine learning model, it could have been possible to predict beforehand that, okay, by looking at the slope, the gradient, that this increase has been continual for too long, and maybe something is wrong, go and investigate, right? So that's already showing that something could be done. But then there was also another case where it's same sensor value, and the time frame this time is not of a breakdown, but rather of just schedule change. So they changed it after 6 months or something like this. But here you see that the temperature values are not going up or going down. It's actually quite more or less quite flat. And this shows that, okay, maybe we didn't need to replace it there. We could have waited until it was showing behavior like the first graph, starting to go towards an upwards trend, and realize, okay, maybe we are approaching a breakdown soon, and then get a few more production hours. Because every time you want to change these parts out, first of all, the production itself stops, which is money lost. And then also the part itself costs a lot of money. So in a grander scheme of things, you would actually save a lot of money if you are doing this in a more optimal way. So this was just the first analysis to sort of say it is worth building a model. And then we decided, okay, what can we do? Let's build a model. And here we thought of, okay, we use the breakdown data. And then we have this sensor data and train a model where the breakdown is basically the label and the sensor values are the features that are used. And then we would train a model so that it can in the future predict based on the learned patterns that, okay, previously when the sensor values were such and there was a breakdown after such time, in the future the sensor values are like this again, maybe there will be a breakdown. So that was the concept. But there were some challenges with it. And the primary challenge with it was, again, data availability. And here the issue was that breakdown data was not really available across factories. So because we have factories in so many countries, in some countries, in most of the Northern European countries, there is good quality data where we find information about exactly when the breakdown happened and why. But then in some of the more southern countries and also in the Asian countries, the data is not really fully in place, and they have more manual records, for example. So in that sense, it was like, okay, we can not really build a solution for all factories, and something we have to think about. But we still wanted to do something in the time being, and that is where we decided to develop a model that does something which I say is as simple as, but it's not really that simple, but simple as doing next day temperature forecasts. So this is just a very, okay, again I say straightforward, but not straightforward, time series model that looks at previous sensor values and predicts future sensor values based on the previous ones. Not looking at the breakdown data at all, because simply that data is not fully available. But here this is an example of some case. I will not go into details again, and of course it shows some timelines. But the idea is that the blue line is what the actual, the blue dots are the actual, and the red is the model that we made. And you can see that it generally does a good job of making the prediction. And what it can help with is more in the sense that it will not tell you tomorrow there will be a breakdown, but as an operator, you see this one day back and you see the forecast of what the temperature or what the vibration or what the pressure might be tomorrow and think, okay, this seems a bit too high. And maybe one day it seems high if the same prediction happens 2 days, 3 days in a row, and you also see the real life trend is following, then you might think that, okay, if in 3 days' time it shows that it's going to shoot up, and you know that it has been giving you the right prediction the last 3 days, then you also believe it, and you think, okay, then I should really go and inspect. So it also touches upon the shop floor, the factory mindset, where we are trying to build on the trust and not saying tomorrow it will break down, because that is too difficult to sell to people, but rather you look at this on a daily basis, see that it actually is doing what it's supposed to do in real life, and then if it suddenly says it's shooting off, then of course you will have more reason to believe in it, basically. Yes. So that was it for the predictive maintenance case, but of course, before I go to the next case, which will be the last bit, it's also, we are just getting started in that project, and it's still a long way to go, where the end goal is, of course, to be able to predict tomorrow there will be a breakdown, something of that sort. And we are in the process of doing data collection and stuff like that to get there. Okay, and then we have a vision use case, and this is a bit more complex than the time series case, where I have a video. But before I play the video, the idea here is that, if you recall, when I first explained the process that we have, is take stone, melt stone, very high temperature, get lava, and then put that lava, spin it into wool. To spin it, it's put on some spinners, which is what we will see in this video. And here it shows how the melt falls on the spinner, on the wheel itself. And we are always trying to control exactly where and at what angle the melt hits the wheel, because it makes a huge difference. Because if it doesn't hit right, as we will see in the video, there can be some splashes where the lava is going everywhere, and there can be smoke, and it's just not a controlled process if it's not hitting at the exact spot that we want to hit it. And right now what happens is that there's basically this would be done in a manual way, where someone is always trying to control the movement of the lava or the placement of the spinner to make sure it's falling in the right place. But then we wanted to do it in a smarter way, where we can see it using computer vision, as you see in this video, where we made a model that is basically able to pinpoint the different areas of interest of the melt. And you can see that there's a line which shows where it hits, and yeah, you can see sometimes it flashes out in the video. That's when it's not really hitting it in the right way. So this was the first part of the project where we actually can find the bounding box of the melt and really pinpoint. So the image on the left is what we got originally. Left, yeah, and then on the right we can see basically how we can point it with some pointers, and that's to show that the vision model is able to detect different location of the melt. And then based on that, once we know that, we can of course control and see that, okay, the box should be a bit more on the left. Then we can control the melt in a way that it goes a bit more to the left. So that's one example. And then in the same way, a bit before this part, before it hits the spinner, there's also the part where we do some smoke detection. And again, this is another computer vision model where you will see, so it says no smoke, and then the smoke comes and it just says smoke detected. So again, it might look simple, but it's not that simple, and it has a huge impact for us because what that smoke, if there's smoke for too long, it will eventually lead into a fire, and that is a big problem for a factory setting. And also because, so that melt is over 1500 degrees Celsius, so it's quite hot. And then if there's a fire along with that, then things will really get bad really fast. So also something like this, where there's smoke or not, in the past this was also done in a very manual way, where we would have someone look at it from time to time and see like, okay, is there smoke or not, or if this area is getting too smoky. But then again, something that we can do with computer vision. Okay, and then we are at the last bit where I do a wrap up. So here, yeah, no words on the slide, but it's just to show a picture of the future. At some point we will have some fully digital factory like this, where this is like a simulation, and we can simulate everything before we do it in real life. Of course, we are quite far from a digital factory like this, But we have started the journey, and we are on that journey, and someday we will get there. So that's the last bit of message, basically, that we are trying to utilize AI, machine learning, and other newer technologies to be able to get to a more advanced place. Questions?
Thank you so much. Shabab, that was a very relevant talk for a lot of people in construction and also manufacturing in general. I think first we'll start with some questions from the room, if anyone have questions, and we'll also take some from the online chat, if any shows up there.
Thank you. It's really nice to see conservative industries actually using this already. I was wondering, how big of a team do you have working with the specifics of the training of the machine learning, etc.?
Yeah, so I think for the data science team, we are a team of 5 data scientists. I have one of my colleagues there as well, who's a machine learning engineer. But yeah, so 5 very core sort of data scientists, machine learning engineer, and then we also have a separate team of data engineers, and that is, I think, a team of three people. And if you include data scientists, data engineers, and also some data analysts in some other part, then it would be around 10, 12 people. So, yeah.
So thank you very much for the very interesting presentation. My question is alongside the acceptance, because we as a company also, we want to work with mines, which is, I'd say, equally conservative as a construction industry. And the main question we have is also how to create that acceptance. Because I like the idea of giving people tools that help them do the prediction, because that's also what we try to explain when we present our work. But are there any other efforts that you have designed to get better acceptance within Rockwool for these projects?
Yeah, so I think basically we have a program called Factory of the Future at Rockwool, and the idea that's a larger program where it's all about digitizing the factories and making all of our factories something of the future, like the last image that I was showing. And that program runs a lot of projects, and I know that one of those projects is also actually looking at exactly this, to do sort of mini micro programs on how do you increase awareness and increase acceptance at a factory level. This includes things like trainings. This includes things like sending data scientists like us to the factory to educate operators. Also includes having full-day workshops where people and representatives from the factories come to our headquarters, and then we show them about what stuff we are doing and what we have in mind. And I think that this one particularly has worked, where we have found across the factories some people who are themselves particularly interested in the tech. And then we try to make them, like, give them a voice and let them advocate in the factory. But again, it depends really, and it's going to be slow. It's not that simple. Specifically when you have stuff like AGVs, so autonomous vehicles, we have quite a lot of those in the factory floor. And those are things that sometimes the people at the factories are not super happy with when it's first installed, right? But it's an ongoing process, and it takes time. That's what I can say.
Other questions? We have one over here.
Thanks for the talk. It was really inspiring to hear about. I'm thinking now you're developing technology that could be applicable to many different places and many different manufacturers. And I just wanted to ask whether you've sort of thought the scenario through where you have some really good technology, and if you would potentially share that with other manufacturers and keep it sort of open source.
Yeah, so yeah, good question. Thank you for the question. I mean, I think in general, we don't mind, I would say, sharing the concept, which is also what I'm doing out here today. And I could also do another little bit of branding where we actually do something similar to this at Rockwool, called the Rockwool AI ML seminar series. And there we are having participants from other companies in the industry to come out and do a talk, and then also discuss ideas with them. So of course it will not be, I wouldn't say difficult, let's say it will not be possible to share the code base, because there it would also mean that we are sharing some product properties, which are of course secret to the business and we're not able to do. But the concept of what we do is of course possible, right? And we are very much happy to do that, and are actively trying to do that as well, if that makes sense. Yeah.
Any more questions in the room here? If not, we'll check what's happening online.
As far as I can see, there's no questions online, but I have a question myself. Thank you very much for a really inspiring presentation. You mentioned, of course, it's a very conservative industry you're working in, and as far as I understand, the solutions you're very much looking into now is sort of how to increase the revenue, how to reduce the downtime of the production facility. But I'm curious to hear if you're also using the knowledge, the AI or machine learning, also to actually improve the product that you are producing, also for a more like sustainable perspective.
Yes, so I think for sure we are, and I think I didn't bring those use cases today, but quality control, for example, was one of the points that I mentioned, and so that's where it's directly involved with the product quality, where we are doing, so one of the cases is also one of the computer vision cases, where we are looking at burn spots, for example, and because the wool can often have some spots that are slightly burnt, and this is a type of burn that you cannot see with your eyes. So you would need an infrared camera, and then it shows up that it's burnt, and that actually, so in a way, it could be sold to a consumer without them even knowing, because it's not a type of burn that you can see with your naked eyes. You need a special filter for it, right? But it's something that we are accounting for, and something where we have also built some kind of systems where even we are using lasers and infrared and other sensors to shine on the surface and find out if there are some defects, and then fix that as well. So that's an example, but there are many other such cases where we look at quality control with AI and machine learning. So, yeah. Oh, something online.
And now I think we have a question online, yeah. And it's Amula Hedge, I hope I pronounced it the right way, who are asking, do you see a generative AI playing a part in your vision of a digital connected manufacturing setup?
Yes, fully yes. I think, I mean, yeah, I don't have that slide, but so we are having generative AI in mind with whatever we are doing nowadays, as is everybody else. And I think it was, I saw on LinkedIn a couple of days ago, Gartner did a hype cycle. They always do one of these hype cycles every year with the technology and show which technology is where and how long it will take to become fully mature. And they had a point on generative AI where it was, so the curve goes, yeah, now they cannot see it online, but it goes up and then down, and then it becomes a plateau again. And they say that generative AI is sort of on the downfall, and it will take 3 to 5 years to get to the plateau, which is where you want to be, basically. So, so having said that, I also, and this is personal opinion, but I also personally believe that that's where the generative AI tech is somewhat at. It's a bit overhyped right now, but having said that, from a Rockwool perspective at least, we do have a project, a few projects actually, where we are trying to build our own internal generative AI solution. I think to start with, like as a knowledge base, right? Yeah, I think to start with as a knowledge base, and then so that we are not going around asking people all the time, and instead ask our ChatGPT alternative basically to do it. But for other more complex use cases, I simply think that it's going to take some time before the tech is quite there yet. So, yeah.
Any more questions in the room? Yes?
Hi, thanks very much. You mentioned at the start that you act as an internal consultant, and then you kind of outlined how this works in kind of the factory context, but you also mentioned that you work with marketing.
Yes.
Can you maybe elaborate
Yeah.
on what that looks like?
Yes. So both I can mention a bit about marketing and also maybe a bit about finance. But basically, we have our marketing team. We are primarily a B2B business, but even then, we still have things like lead generation, and we have things like customer segmentation. So for example, if we have 1,000 different businesses to target, how do you know which one to prioritize? And there we use some, or we're currently trying to build some models that can help you do this kind of segmentation and prioritization. Or if you have 100 or 1,000 open opportunities, how do you, and of course we don't have, let's say, enough colleagues to target all of those 1,000 opportunities with the same kind of time and effort. So which 100 do you focus on? And then you use a model to predict the win probability of an opportunity, and then target more those ones. So that's a use case in marketing, for example. And then, not really specific to finance, but more corporate functions. We also do some email-related cases. So a lot of the times we have some orders and stuff like this coming in through emails, and that needs to go into the database. And usually people are sitting and typing this out, looking at the email and typing it out. But then we can do some OCR and automatically read up from the email and do an input to the database. So also some of those cases. So, yeah.
Any new questions popping up in the room or online? Otherwise, I have a final one. You've shared so many useful cases, and now also in terms of marketing and finance. When you look for inspiration online for how might we use AI in our company, what are some of your go-to resources? You've mentioned the Gartner report and so on. Are there other places that you look to for weekly or monthly
So I
inspiration?
think Gartner, as I've mentioned, I'm looking at them quite a lot. And then also McKinsey is coming out with reports every now and then. So I also read those. But I think what is also important is I go out a lot, like how I'm here today. So I'm attending quite a lot of roundtables and other such talks, seminars and stuff like this, and hear from others what they're doing. And I think that's really the best way to go out and learn as much as you can about what you can do. That's what I can say. Yeah.
And that's exactly what we're trying to facilitate here today
Yes.
as well. Well, thank you so much for sharing some insights about Rockwool and how you're doing it. Let's give him a hand. Yes, the extra time did come in handy. So now I also have time for a little advertising for the next Applied AI Launch Talk. It's not going to be here at Skylab. It's going to be in Østenhallen in Copenhagen, where the Digital Tech Summit takes place. If you scan the upper QR code instead of a confetti thing, I went crazy with QR codes today. The upper one gives you a link where you can register for Digital Tech Summit for free, which is quite nice. It's a 2-day event on the 8th and the 9th of November, where industry and academia and startups meet in Østenhallen. On the 9th, we have Applied AI Launch Talk there. From 12 to 1, as usual. And we have these 2 talks, and you can register for those specifically on the website as well. You don't have to register for them, but it gives us a clue about how many chairs to put up, and etc. If you go to the upper right, it's going to be here. You can register for the online webinar if you know that you're not going to be in Copenhagen, so you can watch it on your computer as you might usually do. But that's it for us for now. Thank you so much for joining, both here and online. I hope you enjoyed the talk. See you later.